Hello and welcome to Vectors Day 2 of Distance Learning. So we're going to go through another sample problem here of what happens when you have two vectors that are coinciding. So like yesterday, we talked about the airplane and the wind and how that wind affects the speed of the airplane. So today, the sample problem that we are going to go through is going to be about a kayaker. And a kayaker is paddling at 4 miles an hour at a bearing of north 20 degrees east. What are the kayak's actual speed and direction if there is a 1 mile an hour current moving east? Round the speed to the nearest tenth and the direction. So we have a kayaker and there is a current in the water. So if you're going with the current, that's going to make you actually go faster than 4 miles an hour. And if that current is going against you, then you're actually going to be paddling a little bit slower. So we're going to have to take the kayaker speed. So kayak speed, and then we're going to have to combine it with the current to get our resultant vector. So we have two. So my first vector that I'm going to draw here is the kayaker speed. And they say that this is 20 degrees north. So when I draw this in here, we know for this information we have 20 degrees in there, which makes this angle right here at 70 degrees. And they say that this is going at 4 miles per hour. Okay, then we actually have a current, and this one again is going to be fairly easy because it's going due east at 1 mile an hour. So due east is an XY, so this one is going to be the 1, 0. So we have to find out what the kayak speed vector is going to be with this. Okay, all right. Alrighty, so what I'm going to do first is I am going to make myself a right triangle down here. Now, some kids like to do the right triangle on the top, which is totally fine. I just have a tendency to like to do mine down this way. So this is going to be my Y value, and this is my X value. So if I'm looking for X first, that is the side adjacent and hypotenuse. So it looks like we're going to do the cosine of 70 is adjacent, which is X, over your hypotenuse, which is 4. So this is going to be 4 times the cosine of 70 is going to be X. Now, if you multiply that out, I think we get 1.368 when we do that. All right, now I need to go in and I need to find out what my Y value is. So for this one, I have the side opposite and hypotenuse. So I'm going to use the sine of 70 is the side opposite over the hypotenuse. So this one's going to be 4 times the sine of 70 equals Y. So when we do that one, we get the decimal value of 3.759. So now we have the vector for the kayak speed and the vector for the current, and we need to combine them. So my resultant vector is going to be when I add these two together, and so this becomes 2.368, and then the current part is 3.759. All right, I'm going to take that resultant vector and put it here on the next page. So my resultant vector, when I take the two and I add them together, we just found out was 2.368 and 3.759. So basically what we have is a new vector in here, and we know that we have this X value and Y value, and the X value is 2.368, and that Y value is 3.759. So they want to find the magnitude or the speed of this, and the speed of this is going to be your distance. So in order to do that, we are going to use the Pythagorean theorem, because remember this is a right angle in here. So we're going to set up 2.368 squared plus 3.759 squared, and that would equal my distance squared. Well, remember to take the square root of that, and I think we get 4.4 miles per hour. So because the original speed was 4 miles an hour and this vector, this current is pushing it, so obviously they must be going with the current to be going a little bit faster. Okay, now what they want to know is what is this direction here? What angle is this at right here? So from this angle, we have the side opposite and the side adjacent. So that is going to be the tangent that we are looking for, which is the side opposite over the side adjacent. All right, remember, whenever you're looking for an angle measure, that's when you're going to have to use the inverse tangent. So you're going to have to hit second tangent, and then your parentheses will pop up. 3.759 divided by 2.368. And I got this to come out to be, they're asking us to round, I think the nearest degree is 58 degrees. So if you're going to do this nautical and you want to know what this part is right here, it's going to be 90 minus 58. And so it's going to be north 32 degrees east. And she's going at 4.4 miles per hour. Good luck on your homework.